Hello, dear students. So the next target is the DC motor and the force on a current carrying conductor. So first of all, we will start our questions from the magnetic effect of a current. So every current carrying conductor have a magnetic field around it. So this is one of the question which is from this concept. This diagram A shows a wire passing through a card. There is a large electric current in the wire in the direction shown. Diagram B shows the same arrangement when viewed from above the card. This is a pattern of There is a pattern of magnetic field lines around the wire due to the current in the wire. So on diagram B, this is diagram B, they're talking that on it, you should draw the pattern and direction of the magnetic field as if viewed from above the card. So the questions carries 3 marks and how we should draw it. It's very simple. You know that the straight current carrying conductor has the circular magnetic field around it, and how to get the direction of it. You know that the right-handed screw rule, it states that you have to adjust the screw in your imagination along the direction of the current, and the tip of the screw should be along the direction of the current. You can now just start imagining that you have to tighten the screw with the help of that. So when you are going to tighten it up, you will notice that it will rotating like this. So in this way, we are able to find the direction of the magnetic field lines. So as it is needed here on the diagram B, so please you have to make around it. At least 3 circles are needed, right? And the last circle should be well away from it. Use the compass to draw the circles and make sure that the magnetic field lines are also there. And these arrows are important to draw to show the direction of the magnetic field lines. In this case, it is clockwise. Okay, so closer to the current carrying conductor, the magnetic field lines should be closer, which are representing that magnetic field is stronger closer to the current carrying wire. And as you are moving further apart, the lines should also be far apart from each other, representing that the magnetic field strength is going to weaken now. Okay, moving on to the next part, force on the current carrying wire. The diagram shows a wire X and Y. This is X here, this is Y here, this is representing the current carrying wire. And there's a large current between the poles of the permanent magnet here. This is North Pole and South Pole. There is an upward force on the wire. Force is also shown to you here. They are saying that you have to tell the 2 different ways of increasing the force due to the current in the wire XY. How to increase the value of current, a value of force on the current carrying wire. The value of force is directly proportional to the amount of current. So by increasing the value of current, you will increase the value of force. Secondly, if you are using the stronger magnet, so again, the applied force will be increased. So 2 things are here which are needed. So one of them is that more value of current, and another one is stronger magnet. Moving on, the diagram shows the wire XY carrying a large current between the poles of the permanent magnet. There's an upward force on the wire. State 2 different ways of making force on the XY acting downward. Like right now is acting in the upward direction. And what you can do or what changes you can make here so that the wire is going to move in the downward direction. So one thing, when you can change the direction of current. Okay, so first of all, if you are going to change the direction of current, the direction of force reverses. Secondly, you can even do like that. You can change the poles of the magnet, like south pole here and north pole on the other side. then again you are in a position to change the direction of uh, force on it. So either you have to change the direction of current, or either you have to change the poles of the magnet. But make sure if you are doing like both of them simultaneously at once, if you are doing it, then there will be no change in the direction of force. Okay, next question. Diagram shows a wire placed between two poles of a magnet carrying a current in the direction of the arrow on diagram. On diagram. Draw an arrow to show the direction of force on the wire due to the magnetic field. Very simple. You will use the Fleming's left hand rule. First of all, Fleming's left hand rule should be applied here. Then your first finger should point from north towards south pole. First finger from north towards south. Second finger along this direction from positive to the negative terminal of the battery like this. Here, when you are applying the rule, you will notice that your thumb is pointing in the upward direction, right? So this is the direction of force which you have to show here on the diagram by making an arrow. So I'm raising all of the stuff which is not needed here. This is the arrow, and I'm drawing it once again. This is the direction of force which is needed here. It is perpendicular to the poles, right? At 90-degree angle to the poles in the upward direction. A student uses two bar magnets to create a uniform magnetic field. He places a current carrying wire at right angles to the magnetic field as shown in the diagram. There is a force on a current carrying wire. The student wants to reverse the direction of force on the wire. State one change that reverses the direction of force on the wire. As we have done previously, it's also the same question. As I told you, either you have to change the direction of current or either you have to change the poles of the magnet. By changing these, any one of them, you can change the direction of the force which is acting on it. Okay, so you can write by reversing the direction of current. Okay. The student increases the separation of the poles of the permanent magnets. State and explain how increasing the separation affects the force on a current carrying wire. So by separating them, it means that you are going to weaken the magnetic field lines. So when the magnetic field lines is weaker, then force will also be weaker. Okay, so force is going to be weaker here. This is a model train uses an electric motor. The motor has a coil of wire in the magnetic field. The diagram shows the coil in the magnetic field. So describe two ways in which you are increasing the turning effect on the coil. Turning effect is directly proportional to, if I'm representing the turning effect with T, it is directly proportional to the value of current. Turning effect is directly proportional to the strength of the magnetic field, right? So if you are going, and it is also directly proportional to the number of turns. So more turns, more turning effect, more magnetic field, more turning effect. And if the value of current increases, then you are going to increase the turning effect once again. Okay, so you can write any two of them. The diagram shows a simple DC electric motor. The coil rotates about the axis when there is a current in the coil. The coil is connected to the rest of the circuit by the brushes. State any differences a stronger magnetic field makes to the rotation of the coil in the diagram. So if we are going to change the magnetic field, like you are going to increase the magnetic field strength. So once again, the turning effect will be more, like you can say the coil will rotate faster as before. So here in the next question, they are going to increase the number of turns. And they are saying that if you are increasing the turn, then what will be the difference that changing the coil makes to the rotation of the coil in the diagram. Once again, as I told you, the number of turns will affect the turning effect. So more turns means more turning effect. So here, if you notice, it's changing from 1 to 2. So more turning effect will be there, or the coil will rotate faster if there are more turns on it. Okay, so if you are going to change the polarity of it, like initially it's positive here and here it's negative. So when we are changing the sign here, so what happened that the direction of rotation reverses, right? So whatever the direction is previous in the previous case is, it will be reverses. So it's better to write that the direction of the motor here reverses. State two factors that affect the strength of the magnetic field of an electromagnet. So how you are going to increase the strength of the magnetic field of a magnet. You can increase the number of turns around it, and by increasing the current, in this way we are in a position to increase the strength of the electromagnet. Here in this question, they are saying this is the diagram given to you, and they are saying that what is the name of this electrical device. Very simple, it's a split ring commutator here, and all the diagram is related to your DC motor. So you can write that this is a motor. Um, in the next part of the question, they are saying that this diagram shows an electrical device. The coil rotates in a magnetic field when connected to the DC power supply. You can tell two changes to the electrical device that will make the coil in a device rotate faster. Once again, same question, use the stronger magnet, increase the value of current, or more number of turns on the coil. So if you will write it, you will get the answer. So now this is one of the question which is a little different. Like you can see that previously we are getting the same type of questions. Now here, this is the important question, even that you have to explain the purpose of the split ring commutator here. This question carries 3 marks. Split ring commutator is this part. This is the split ring here. A single ring is split into 2 portions. And we need to tell them that what is the purpose of this split ring commutator. So the main important function of it is that it will, because of this, the coil keeps rotating in the same direction. This is very important function of split ring commutator, that the coil keeps on rotating in one direction, in the same direction. Either it will be the clockwise or either it will be the anti-clockwise. So how it happens actually? It will be possible by changing the direction of current in the coil every half cycle. So whenever half cycle is completed, the direction of current reverses. And because of this, the coil will keep on rotating in the one direction, right? So this is the now a very important question. Please go through it properly. The next thing is that this diagram shows a simple direct current motor. The voltage of the power supply is increased. State the effect this has on the motor. So if you are increasing the voltage of the power supply, then the coil will rotate faster. Very easy. The next part of it is this diagram shows the simple electric motor. There is a current in the coil W, X, Y, and Z. The direction of this current is shown by the arrows. On the diagram, draw an arrow to show the direction of the force acting on the side WX, and an arrow to show the direction of force on the side YZ. So 2 arrows are needed here. Again, you need to apply the Fleming's left hand rule. Your first finger will point from north towards south pole. Your second finger along the direction of the current from positive to negative. Then your thumb is pointing in the upward direction, which is 90-degree angle to both of them. So force in this case will be in the upward direction and your downward direction. So the coil will rotate clockwise. So only the arrows, these arrows are needed here. I'm going to raise the extra one so that it will be easy for you to understand how the direction of force is needed here. It's like this, right? I hope that the DC motor is very, very clear to you now. Please watch my upcoming videos as well. Like and subscribe my channel. Thank you once again. Take care. Bye.